Hey, so I'm going to do a quick video on how to use Excel for Euler's method. So this is Weber 12, problem 12, and our step size is 0.1. So I'm going to hop over here to my spreadsheet. I'm just going to make a note that my step size is 0.1. And let's see, we begin with, so when x is, okay, so we're going to begin with x equals 1. And when x equals 1, y is equal to 0. That's what this equation over here is saying. We want to stop when x is equal to 2.4, and we're going to take a step size of 0.1 and our differential equation. So our slope at a given xy value is negative the x value minus the y value. So our slope is equal to negative the x value plus negative the y value. Okay. So then your new estimate. So what's here is sort of y of your initial x value plus your delta x. Okay, this is what we're trying to estimate. It's equal to your old y value. So here's my old y value plus your slope times your change in x, which is just 0.1. So that's all great. And this is going to be equal to, so our next iteration is our old x value plus 0.1. So now if I sort of hold this little corner thing here, if I can get right there, it goes, and drag it on down, we can drag, and we want to get to essentially 2.4. So I'll go ahead and just delete these really quick. Okay, now that all of that is filled in, I can highlight all of this. Oh, oops, sorry. So now what goes in this box, this is supposed to be y at 1.1, right? Y given my x value, and my x value is 1.1, but that is also what we computed over here. So actually this box is equal to this box, okay? All right, and now I can kind of just drag this down, and what should happen, let's see. Yeah, so my slope at when x is 1.1 should be negative the x value plus negative the y value. So that's what's happening here. So that automatically fills in your slope. And then similarly, if you just drag this down, it should use the same sort of thought process, which is to say that your new y value is your old y value plus your slope times 0.1. So, okay, now that all of that's happening and we have it all sort of referencing the previous row, we can drag this down here. And let me just make sure that all this is looking good. And so I'm looking up in here, just so you know, and sort of making sure that it just sort of continues to look like the same formula, it all indexed correctly. That all seems good. Let's go ahead and test it. So this right here is supposed to be y of 2.4. This value is y of 2.3, right? X is 2.3, and y of that value is right here. Here's the slope, and then this is the computation to get y of 2.4. This number would go right here, but whatever, I'm just going to take that number. So negative 1.4. So if I go over here, this is approximately negative 1.4. I hit submit. There you go. So I hope that made sense. Just to recap it one more time. So I have the initial x value, and then I'm going to tell Excel to add my step size to the previous x value. And once I tell it to do that, you can just kind of drag this all the way down and it'll fill in that column doing the same thing. So you can see that pattern happening. Y of x, well, we need to have our initial condition. And then here we use our differential equation. Our differential equation was negative x, negative y. And so I take negative this plus negative that, and that's how we got this number. So that's what's going on here. Then right here, we do the linear approximation formula. It's y plus y prime times delta x. So that's what's going on here. And that's what this formula is up here. And then you have to teach it to take this number and feed it in here. And then you can just drag and drop. Anyway, all right, great. Let's stop the recording.